Hello, everyone. Today we're going to be talking about literacy in science, particularly the four pillars of literacy and the importance of learning vocabulary in the context of science education. Before we can apply it to science, we got to define literacy itself. Literacy is not only just the ability to read and write, that's what we normally think of when we think of being literate, but it's also competence or knowledge in a specific area. A specific area for us is our content, earth science, content area literacy. So, for our sake, you have to be literate in science to be able to think like a scientist. You can't have a scientific thought unless you understand the process that you're thinking about and what kind of factors influence that process and what is before and after that process and the steps in that process. You have to know science to be able to think about science. It makes sense, but you have to actually dive into it and learn the vocabulary, learn the language of science. There are four pillars of literacy: reading, writing, listening, and speaking. Two of those pillars have to do with taking in information, and two of them have to do with giving it out. Reading and listening, what you're doing right now, you're consuming the information in my presentation to you. I am writing, I wrote the presentation, and I'm speaking. I am taking information that's inside and communicating it to you. Literacy in the academic language. Science is a language. And I said that before, and I'll say it probably more times in this presentation, but that's the whole point of being literate in a subject. Science is a language. You have to be able to store and access knowledge about science. You have to be able to communicate that information that you have. Being literate allows you to do that. It also allows you to make connections between concepts, like I mentioned on the last slide. If you have a certain process, if you are literate, you'll be able to know the steps before, the steps during, and the steps after that process, what factors determine that process, what that process affects. You would know, I would hope, if you're talking about it, you would know most of or all of that. Before we do our activity, I want to talk about what happens when there's a lack of communication and how important it is in science to have good communication. There was an incident in 1999 with the Mars Climate Orbiter. The orbiter only cost about $125 million, and it crashed into Mars due to a miscommunication error. They were trying to get it about 226 kilometers above the surface. It ended up about 57 kilometers above the surface. And as soon as it came in contact with the Martian atmosphere, it vaporized. It was gone. The two main organizations working on this project was JPL in California, Jet Propulsion Laboratory, and they were using the metric system, millimeters, meters, kilograms, all of that. And the other one was Lockheed Martin in Colorado. They were using the imperial system, inches, feet, pounds, all of that, which is fine. Use your different units. That's all good. The problem was the miscommunication. Somebody forgot to mention it, or they didn't notice that there were two different systems of measurement. And it resulted in the complete catastrophic loss of the vehicle, which is bad. It not only cost $125 million, it was years of research and development and time and people's jobs, and it's a big deal. According to John Logston, who was at the time the director of space policy at George Washington University and a member of the NASA Advisory Council, said, as you can read there, fundamentally, you have partners in this enterprise speaking different languages. And just like a system of units, just like the imperial system or the metric system, science itself is a language. And without being fluent in that language, things can go bad. Communication is very important in science. Do not forget that. That's the whole reason for this lecture. That's the whole reason for learning vocabulary in this way. And because it's so important, let's learn some vocabulary. In today's assignment, you're going to split into groups of 4. You have a total of 15 key terms that are all on your assignment, and they're in the first column there. And then after that first column, you have 5 other columns. They're the discussion definition or the pre-knowledge definition, the research definition or the dictionary definition, characteristics of that word, so what you need to make that word possible, what you need to make that definition happen, and examples of that definition. And then the last column is what I'm going to call your pre-knowledge rating out of 5. You're basically going to score yourself and see how well you already knew the word. If your discussion definition is exactly like the researched definition, that's a 5 out of 5. If it's nothing like it, it's a 0 out of 5. This is not your grade. This is how I'm going to see. This is a gauge for me to figure out how much you don't or do know about these words, so that we can focus on certain words or certain concepts throughout the unit. Before I hand it off to you guys, I'm going to let's work through an example. So the very first word on your sheet is dew point / saturation point. Saturation and dew point are basically the same thing, so I clumped them together because they're basically the same thing. If we were in person, we would have a little discussion and come up with a useful definition that we sort of all agreed on based off of our current knowledge. And maybe we could come up with something like the temperature that dew forms. We know that dew happens overnight at some point, and we know that it gets cooler at night. So we might decide, maybe the dew forms at a certain temperature. Okay, sure. Then we do some research, and we get a definition that is this. We get the temperature at a constant pressure at which relative humidity is 100%. Essentially, that's the same definition, but we have a lot more information. We need a certain pressure, and we have relative humidity is 100%. Okay, well, what does all that mean? It's good that we have relative humidity in this definition, because if you look down further on your assignment, you will see that we need to define relative humidity. Connections between terms and concepts. That's what we're looking for. We're using our 4 pillars of literacy as we complete this document, and we'll be discussing and communicating and making connections and hopefully becoming more literate in this unit, in our clouds, fog, and dew and visible moisture in the atmosphere. That's our unit. So characteristics of saturation and dew point. We know it involves temperature. We know it involves water, be it water vapor or precipitation. We know it involves pressure, and it involves relative humidity, or the amount of water the air can hold. And lastly, we look at our examples. We know that at the dew point, dew and fog happen, so we can put dew or fog in the morning as an example, and the condensation on the outside of the glass. So I have a cup here, but it's not really condensating. When your glass is sweating, condensating on the outside, that's also when the air reaches the dew point. So those are both examples of dew point and saturation point. And I would give us overall a 3. We got the definition right. It is technically the temperature that dew point, or the temperature that dew forms, but that's only about half or so of the actual definition. It's the temperature, but it's also the pressure, and it has to do with the amount of water vapor in the air. So we got part of it. We missed part of it. We did all right. We got about a 3. And that's all we have for today. You can have the rest of class to work on your assignment and turn it in at the end of the class.